Hello everyone, in this video I'm going to go over the test lamp. Okay, so this is my test light. I've got a ground clamp here on this side that I can attach, and then on this end over here, this is the probe. Okay, and inside, right in here, there is an incandescent bulb. Okay, and so this is mostly just a quick tool to determine if you have power and ground. You don't know how much power or ground you have because there's really no way to tell by the brightness of this bulb whether or not you have a full 12 volts in your at any point in your car or less. Your guess is really as good as mine as to how bright that bulb has to be to say that it is 12 volts. But you will be able to tell that there is some difference in voltage. Okay. And so if you're looking for circuits that are just completely dead or completely or working well, then this is a quick way to do it rather than using a multimeter. So now I'm going to explain the circuit that I've got as well. And it's just a simple one, but here's my battery. I've got a power terminal or clamp, and then I've got a circuit protection device, a fuse. My load is a bulb, and it is connected to a ground wire and this ground terminal of my battery. Okay, and in my bulb, we're just going to use one filament, but if this is properly functioning, I turn on my battery and this illuminates. Okay, and so we'll go over basically this test lamp and using it in a circuit like this, and then also what you might see if the circuit is not functioning properly in certain conditions, okay, or situations. So what I'm going to do first is I'm going to take this and I'm going to connect it to my ground clamp, get some of the wires out of the way, and turn this on. Okay, so if I was to take my test lamp now, I can see that everything's functioning. This bulb is turned on. But if I go over here to the power side, power terminal, it's the lamp is illuminating inside my test lamp. What's happening is I'm connecting it to ground, I'm connecting the probe end to power, and a separate circuit is being created here through this bulb, through this wire. Okay, and so in order for this to light up, it also needs power and ground, right? You could say that these circuits are in parallel. I've got this circuit out here that illuminates this bulb, and I've got a circuit here that illuminates the bulb in my test lamp. They're operating in parallel. All right. Now I can use my probe to come down to each point that's exposed, even the points on my fuse, and I can see that it is illuminating all the way up to the bulb, up to this connection in the bulb. Okay, that means that 12 volts or so, I'm not sure how much exactly because this doesn't tell me. It only says that there's a difference in voltage. It's available all the way up to this point. Okay. Now, what do I see on the other side? On the other side, because I have my ground clamp connected to the negative terminal, I start coming over here and my test lamp is not illuminating. That's because there is not enough difference in voltage on that side of the circuit to cause this to illuminate, right? The lamp is not getting any power because all of that voltage is being consumed really in this test lamp or in this light bulb over here. And the other thing to keep in mind is because we're only looking for a difference in voltage, I could put this on the power side and this over on the negative side, and again, that difference is causing this bulb to illuminate. All right, so I could come to each point over here, and I could see that it illuminates. But then on the other side, at each of these points, it does not, right? Because there's no difference in voltage on this side, and there is a difference when I bring it to this other side, to the ground side, when that clamp is on the power side. Okay, the reason that you're using this is because you're trying to quickly find where you have a break in voltage or in continuity. Okay, and so say this happened. My connector got disconnected from the wire in my car. I don't see that. It might be behind a panel, but I'm just quickly trying to figure out where this is occurring, what's happening. So I'm going to try and basically trace voltage or the difference in voltage to find out a quick location. And so what I could do is I could have my clamp on my negative battery terminal. I could turn it on. Of course, that's not working. And I start going through the different places. Yep, there's a difference there, difference on both sides of the fuse, both sides of the fuse. In other words, that voltage is available all the way up to that point, and even to that point on the bulb. Now, something interesting is that because the connection is here, this infinite amount of resistance is here on the negative side of this bulb. Infinite amount of resistance is obviously infinitely more than the 3 or 4 ohms that's coming out of this bulb. Okay? So not only does it light up on this side, but it also lights up on that side. So if I have a break in the negative side of my circuit, um, between my negative battery terminal and my bulb, and I am probing this connector and I see that it illuminates, you can basically isolate this side of the circuit. Okay, I could say the same thing for the other side. If that happens, ground clamp still in the same place, that's okay. Again, difference in voltage all the way up to through the fuse up to this point, and now there is no difference in voltage between this clamp going through the wire and even through the bulb up to that point, right? It's all the same. So that's just something to keep in mind. If an assignment asks or states that you are seeing the test light lamp on both sides of the bulb, it's possible, and you have a known good bulb, it's possible that there is either high resistance or an infinite amount of resistance, which is an open on that one side. Okay, where you see that difference there. Now, that's using a test lamp. Now, what happens when I identify what I see there? I'm probably going to start breaking out my multimeter if I can't see what's going on specifically or as quickly. I'm going to bring out my multimeter and I'm going to see what's going on. So what I'm actually going to do is I'm going to show you with the multimeter kind of what's happening in the circuit. So if I turn it on, I can see it's functioning. And I've got my multimeter to volts DC. And you can see that as I'm measuring this, there's 12.29 volts available from the battery. And as I go down the line to each of these points, to each of these points, 12.27, there's a little bit of voltage being consumed in the wires until right before the bulb. But then after the bulb, there is very little difference in voltage. Okay, so that's exactly the same thing that we were seeing with the test lamp. You just don't know the values. Now, if I break this circuit and I know that my battery is still functioning properly, it's still got some voltage, I could use, if I'm using my multimeter, I'll always come to the battery first to determine how much voltage is available there. So 12.3 about. What am I seeing all the way down the line? 12.29, 12.3, even on that side, okay? So because there's an open here, that voltage is available all the way through the bulb, all the way up to that point where the circuit is no longer continuous. And then after, 0 volts. zero difference in voltage. Okay. And you could do the same thing again on the other side. I could do this. If the break was on the other side, I'd do the same thing. Again, 12.3, 12.3, 12.3, 12.3. Now, 0 volts difference, okay, between this point and my negative battery terminal. And that is kind of a demonstration of what's going on when you are diagnosing some of these circuits, or working through some of the problems in uh, our worksheets or activities. Okay. Now, I'd just like to say that one of the things that you want to do first when you're using a multimeter or a test lamp is, say this bulb was not working, what you'd want to do is get the clamp on the negative battery terminal and just start first, make sure that's fine. I'll just throw that over there and we'll pretend like we're not seeing anything. And I'd test there. Yes, there is voltage, a difference in voltage. There, no. I could come over to the other side and just make sure that there's a difference in voltage there. That means everything is at least continuous up to that point, and there's nothing there. So I could do that real quick. If I use my multimeter, and keep in mind, whenever you're doing diagnostics on components, you should be able to really have a good idea what the problem is in 3 steps. Okay, uh, the very first step is to know how much voltage drop you should be dealing with. Okay, so 12.28. Okay, so that's the very first step. But say my light bulb isn't working. Okay, there's 3 more steps. The first thing I want to do is check on either side of the bulb and make sure that that's dropping enough voltage. Right now it says 12.21. If that is the case, then my bulb would be bad. All right. If I'm still dropping all the voltage through this bulb, or you could say between this section here, that means my bulb is bad. If it's not working, okay. But oh, but if it wasn't dropping all the voltage, so step 1 is check voltage drop across your component. Step 2 is check your voltage drop across ground. Okay. And if that was disconnected, you would see that difference in voltage there. All right. Step 3 is to check voltage drop across power. And 2 and 3 can be interchanged. It doesn't matter so much. But that's just something to keep in mind. 3-step process. And then from there, you should be able to have a really good idea of where you want to look next. So, so if that was disconnected, you could see that there's 12.27 volts difference between there. That would basically condemn this side. Now all I have to do is determine if it's actually the wire itself, a connection, or the fuse. Maybe the fuse is blown, or maybe there was a switch in there, and maybe the switch isn't closing completely, But step 1 in diagnosing any of this stuff is check voltage drop across the component. Step 2 and 3 are to check the power side and the ground side. Okay, and that's how you determine where you're running into your trouble. Okay, so I hope you enjoyed this video. Again, that's basically how the test lamp works. And keep in mind some of that stuff you're working through if you're working in other assignments this semester and it talks about test lamps, you may want to come back to this video and review it a little bit and make sure that that there isn't something that you missed or that you understand it completely. And as always, please reach out if you have any questions at all, and we'll make sure that your questions are answered and you have a good grasp of this concept.